Hi everyone. In today's presentation, we'll be discussing the professional practices and delivery of our solution, the e-learning platform. Multidisciplinary team technical skills. The development of the e-learning platform would require a multidisciplinary team with both technical and non-technical professional skills. The technical roles that have these skills include the following. Taking a closer look at each, software developers are responsible for constructing, designing, and maintaining applications or websites using scripting and programming. Web developers are more suited to this project as it involves web technologies. These developers have roles within the subcategory such as front-end developers who deal with the user-facing software and back-end developers who deal with the server-facing software. They require strong programming skills in an array of different coding languages such as JavaScript, Python, or C#. For web developers, they should have skills in coding languages used for web technologies such as HTML, CSS, React, and more. Problem-solving skills and critical thinking is a must for these roles, as well as software development methodologies too. UI/UX designers are responsible for the design, functionality, navigation, font, and color of the platform. This ensures intuitive interaction for users and allows the ease of use for both teachers and users. They must be proficient in user-centered design to ensure the system meets user needs. They should also be skilled in producing wireframes, prototypes to visualize interfaces which aligns with project requirements. They should have extensive knowledge in mobile design principles and the responsiveness of certain devices in order to design an interactive and user-friendly platform for cross-device compatibility. Testers and debuggers are responsible for testing, deploying the software, whilst ensuring seamless and efficient functionality. They should be proficient in software testing methods such as unit testing, integration testing, and system testing. They are required to have a strong understanding of bugs and bug tracking in order to perform appropriate security testing to identify and eliminate vulnerabilities and bottlenecks. Project managers are required for coordinating tasks, managing deadlines, and ensuring that the platform is delivered in line with the educational objectives. They must be proficient in project management methodologies such as Agile and Scrum, so they can manage iterative development for the project. Some skills required include risk management and stakeholder communication. This ensures that they align with business goals and maintain clear communication with stakeholders to ensure timelines are followed and objectives are met. Network engineers. Network engineers are responsible for deploying, designing, and maintaining the organization's computer network infrastructures. This includes local and wide area networks as well as cloud networks. They make certain that the network performance is of standard and assess the security and reliability of these network systems. They are required to know the type of topology, the maintenance and deployment of fiber optic cables, as well as an extensive knowledge of network protocols such as TCP, IP, DNS, and DHCP. This ensures security and operability of the network. System administrators are responsible for managing the servers and operating systems to ensure that systems are stable and available around the clock. They monitor system performance and availability and implement backup and recovery procedures in case of incidents where data is lost or corrupted. They must be proficient in operating system administrations as well as user and access management in order to implement, update patches, and role-based access control. They also need knowledge in backup and disaster recovery procedures to minimize impact on the platform when experiencing data loss and downtime. Cybersecurity specialists. Cybersecurity specialists are needed to defend the system from cyber attacks and data breaches by implementing security measures and responding to and monitoring system activity, as well as incident reports. This is crucial due to the nature of the data the e-learning platform handles. Therefore, a thorough knowledge in security frameworks, networking, and firewalls are required core skills for this role. Furthermore, knowledge in programming and scripting is important for automating tasks and setting up alerts for serious incidents. Being proficient in risk management and incident report is another core skill that professionals need to assess the risk factor of certain breaches and implement the appropriate security measures in place. Finally, architecture engineers are responsible for designing the cloud architecture that meet business requirements for availability, scalability, and performance. They must select the appropriate cloud service model, such as SaaS or PaaS, and apply security controls to the cloud. They must be proficient in cloud security principles to ensure a secure cloud environment for users, and they must be able to select the correct cloud service that meets the project's needs and is the most cost efficient and resourceful option. Moving on to non-technical team skills. Non-technical team skills are significant in the project's development and include the following. Team collaboration. Team collaboration is essential because team members must share their progress and discuss changes to ensure consistency in the software. Another important skill is time management. Time management ensures that everybody is able to complete each stage at the same time for consistency. Effective teamwork is also a critical skill in the networking part of this project, as miscommunication will lead to errors in configuration or security vulnerabilities. Problem-solving skills are important with connectivity issues and network performance. And finally, a professional attitude, which includes upholding ethics and adhering to standards, legislations, and correct documentation, helps ensure the platform is maintainable and reliable. Communication methods. The design and implementation strategy need to be communicated appropriately using a range of communication methods. This differs for non-technical audiences and technical audiences. When addressing technical audiences, we need to consider the following. A written report with technical jargon. The primary method of communication with technical audiences would be a written report to document the requirements, software decisions, network architecture, and security approaches. This report would need to be written in a professional format for understanding and clarity. Another communication method would include complex visual diagrams. Complex visual diagrams such as UML, system topology diagrams, security infrastructure, logical network diagrams, and wireframes represent the real-life physical aspects of the project as well as its functions and how users will interact with it. Also, tables would be used to present IP address relations, device roles, and security policies. These communications would primarily be used for technical stakeholders. For non-technical stakeholders, we need to consider the following. Using simple presentation slides. Simple presentation slides would be the most appropriate when communicating key processes of the project. These slides will focus on benefits of the platform, which includes accessibility, scalability, and the social impact this platform has, rather than discussing the technical implementations of the design. We would use simplified diagrams and tables to encourage further understanding and clarity to support the outlines of the project and avoid unnecessary technical jargon to communicate key ideas. An example of this is when explaining the choice of using cloud technologies rather than on-premise. We would mention user preference and economical benefits rather than discussing the storage capacity and comparing the robustness of modules. Why should we adapt the content to suit different audiences? Although communication methods used may differ between technical and non-technical stakeholders, it's important to consider that there is a skill and knowledge gap. When addressing each, we need to adapt the content by doing the following. Consider language used. We need to consider the language used when presenting to each audience. When addressing a non-technical audience, you need to simplify the language and cut out technical words and concepts and replace it with relatable ideas instead. Appropriate visual design. Providing simplified slides and visual summaries are appropriate for these stakeholders, such as educators and decision makers, as they're more concerned with how the platform supports learning outcomes rather than the technical benefits. For a technical audience such as developers, designers, and engineers, it's more suitable to use the proper technical terms when discussing project processes and use UML diagrams and structured documentation. Regulate the amount of detail included. It's important to provide them with details that are precise on the system behaviors and operations as they will be potentially implementing them. By adapting communication styles for each audience ensures both parties are included and fully understand and engage with the project effectively. Legal requirements. It's important to consider both the legal and ethical requirements when designing an e-learning platform. The platform must comply with all data protection laws and regulations, which includes the following: GDPR or General Data Protection Regulation, the Data Protection Act 2018, LED or the Law Enforcement Directive, and security policies and best practices. These laws ensure that personal data remains secure and protected correctly and lawfully. We must comply with private policies and data privacy regulations, giving customers a clear expectation as to how their data is being handled. It also gives a level of trust. However, failing to comply results in needing to spend thousands on fines, causing financial damage, which affects student learning and project mission. Legal requirements also cover security policies and best practices, as these ensure the legislations are met and adhered to. Role-based access control would need to be implemented to prevent unauthorized users from accessing information relevant to their role. Security best practices such as password policies must be taught and implemented to all stakeholders. This ensures data integrity as it reduces the likelihood of data breaches and loss. Network designs must also consider the ethical and legal responsibilities concerning data protection and data security. By complying with the GDPR and all the other data protection law acts, users are confident that their data is safe and protected properly when transmitted across networks or stored in cloud environments. This ensures using security controls such as authentication, encryption, and network segmentation helps to protect against security attacks. Ethical requirements. It's important to consider ethical requirements as the platform should be inclusive and accessible. These following considerations should be applied. Inclusive design principles. The platform should promote fairness and accessibility for digital inclusion. This is implemented by UI/UX designers, where they implement inclusive design principles and avoid certain features that may disadvantage users when implemented. This would disadvantage users specifically with limited technical skills or disabilities. This allows for more users to utilize the platform, increasing user interaction. Another ethical consideration is the transparency of data handling. The transparency around the platform's usage of data must clearly define and implement clear and honest consent mechanisms in the actual software for users to select. This maintains trust among students, parents, and teachers as they know where their data is stored and how it's being used by the organization. Networks should be designed to support all connections and ensure availability. This ensures users have a reliable connection to services. Also, network monitoring must be executed responsibly as it needs to consider both security risks and respect the privacy of users. This can be achieved by adhering to standards such as the NIST framework that supports best practices in network security. Business approaches. All the approaches that have been taken in this project reflect best practices when designing and developing the e-learning platform for rural environments and user needs. The design tools used reflect the combined software and network nature of the solution. It uses clear documentation and recognized design tools for planning, which demonstrates a systematic approach to problem solving. Both legal and ethical considerations have been integrated throughout the design phase rather than being considered after the completion of the software. Using both cloud computing and a fiber optic connection gives a more effective solution than on-premise infrastructure for rural schools. This is because cloud removes dependency on physical devices and fiber optic cables, providing an uninterrupted and consistent connection at all times, making them practical due to the lower costs and maintenance requirements. This together makes a scalable solution that supports consistent access to education without the challenges that are faced due to geographical location. The proposed solution supports user inclusivity as it addresses key barriers to education, such as limited access to learning material, resources, and unreliable infrastructure. By centralizing the platform in the cloud, all schools and students gain an equal footing as they are exposed to the same educational content and teaching services. Fast fiber connections ensure there are no disadvantages due to delays and downtime, and the e-learning platform is accessed on a stable network connection. The project considers stakeholder needs, scalability, and risk management, and the justification of the design decisions demonstrates a realistic and professional approach. Furthermore, the security and data protection implemented throughout the project reflects industry best practices for the system's handling of sensitive data. The main limitation is the dependency on internet connectivity, as access to the platform heavily relies on a network connection. However, these risks can be mitigated by the reliability of fiber optic networks as well as redundancy. This can be addressed in the later development phases where an innovative approach may be taken. Overall, the proposed solution proves that it incorporates both realistic and professional approaches to design the e-learning software platform that is well connected and meets the needs of rural schools. Thank you for listening.